Yeah.
Okay, so
I don't know. I like to clean the fish. People like to eat them afterwards. Well, I don't know.
Sometimes you just want to do nothing.
I clean fish in like 15 seconds.
okay, we're gonna do the lab now, which is right here. So for the lab, I have a link that provides all the same text. So this is actually a little bit more step by step than some of the other labs, but the tools themselves, I don't like to say where they are, but you run some tools. It's pretty long. I'm just going to go ahead and download the data to show you how to get started. So here, when you download it, it's a zip file. The best way to do this is to take the contents of the zip file, which is called regression, and copy that to somewhere on disk. I'll just put it in ctemp in my case and paste it. Okay. I'm going to close down this project, save it, close it. You could leave it open if you want, but there is actually an ArcGIS Pro project inside of this data set. I mean, inside of this folder. So make sure that you extract it so there's not a zip file in there. So the zip file in the path. You take that folder out of the zip file, put it somewhere else in your directory structure. Then you can open the project, and when you do that, the data for the project will automatically be loaded because I told it to save relative paths rather than absolute paths.
This is week 8, isn't it? Past week 8.
Yeah, lab 8.
Yep, it's lab. It's under the regression in GWR in ArcGIS Pro. Yeah. This class I don't always use the week number, but yeah, this is the 8th lab, I think. Okay, so when that opens up, it'll open up in ArcGIS Pro, and this is Portland, Oregon. So we zoom out here. Well, I can't really see much of the surrounding area, but all this data is for Portland, Oregon. And you have a number of these are actually census tracts, and they have these data in them. They have the number of 911 calls, the population, the call rate, the number of jobs, the number of people who don't have a college education, the distance to the center, the renters, the unemployed, number of businesses. I forgot what not in LF means. Foreign born, self-explanatory. I forgot what this one is too. It has something to do with alcohol. And then you have a bunch of variables in here. More variables than we had with the example that we did in class. Okay. But what you're going to do is you're going to follow this lab through, but just use the data the way it is, and you're gonna follow the directions here. So you're basically a community, which in this case is Portland, Oregon, and you spend numerous public resources responding to 911 emergency calls. And so projections show that this is going to double over the next 10 years. And we want to know how that population growth is going to affect our resources and ability to respond to emergency calls. So maybe we could use the information that we're going to look at to decide where to situate police and fire stations. Maybe we could use it to reduce the number of 911 calls. Maybe we could use it to implement policies on how to manage 911 calls in the future. But we're going to use regression to help us to determine the causes of 911 calls in the city. So just from that sentence right there, what is our response variable now going to be? Because it's not going to be the average date of the last spring frost. It's going to be what?
Call rate of calls.
Yeah, the call rate of the calls. It's going to be the 911 calls. So I've already followed you through this. Okay, you get the data from Canvas, download the prior project, and you just double click it to open it. That way you'll be all set, you'll be all ready to go. And now you're going to explore the data. Okay. Now, some of you have probably been to Portland. I've been to Portland. But not everybody here is going to be familiar with Portland. But even if you're not, even if you are familiar with the the patterns that exist inside of Portland, it's still a good idea to first just kind of look at the data. And so one of the things that you could do is to just explore some of the other data patterns. So right now we've just got 911 calls, right? How do we change what we see? We could just go in here, symbology, and instead of calls, we could choose population. Okay. So calls may just be related to population, and if they are, then what does that tell us? As the number of people increases, so do the number of 911 calls, right? Like, does that tell us anything important?
You need to put the stations where there's more people.
Yeah, so basically, it would tell us that there's not really any pattern, and it's just the people is the pattern. Where there's more people, there's more 911 calls. Just looking at this, okay, there does seem to be some relationship, but it doesn't appear to be very strong between those two patterns. I mean, there's some areas down here where there's hardly any 911 incidences, but there's a fair bit of population. Now, there's going to be some data that's related. So here's median income. And look, those same areas down here that had a low amount of 911 calls also had, and actually had a high amount of population, also had a low amount of 911 calls. So they have high income, high populations, but they end up having low 911 incidents. That makes sense, right? Having more people, if maybe their income is higher, won't have as many 911 calls. Yeah, go ahead.
Yes, could you overlay a county map on top there just to see the makeup of how they break down? Because this looks like a blob. Is there a way we can take one of the overlays for county?
Well, you could change your base map. You could change the base map to this like topographic map, and then turn off the hill shade. So this kind of shows you where you are.
Could I use that hexagon thing to tell me where, okay, and you zoom in, you can see breakdown of the neighborhoods. So then you start making analogies to run the numbers.
Looks like Beaverton, but higher population.
Yeah, I mean this area doesn't include downtown Portland, but it's one of Portland's suburbs is a better way to say it. Okay, so it's Beaverton, Oregon, but then what we're going to do. So we've already noticed a few patterns. You're welcome to keep looking at additional patterns, but we've noticed that maybe income is negatively correlated with 911 incidences, and population is probably not really correlated all that well at all with 911 incidences. Okay. But what we're going to do is look at the relationship between 911 call volume and population. Okay. You can examine this relationship between the numbers using the OLS regression tool. So what's the dependent variable in that situation? So here's ordinary least squares. What are we trying to predict?
What's gonna have the most calls?
Yeah, we're trying to predict the number of 911 calls. So that is, just use the unique ID field there. The number of 911 calls is the dependent variable. That's what we're trying to predict. So that's calls. And the exploratory variable for at first it should be just population. We can output a report file if we want to. Let's call this just pop. All right, so this is 911 incidences as a response to population. So they're showing us where the big residuals are. These are the big positive residuals. So if I click there, I can see that the estimated value is 99, and the actual the actual value that I'm trying to predict is calls, which was 167. So I predicted 99, and there were actually 176 calls there. So we were off by the 76.7. We underpredicted the number of calls. So we're underpredicting calls in this area, and we're overpredicting calls in these areas using just population. So these areas, according to our model, should have more calls, but they don't have enough. And these areas, we predicted less than the number of calls.
So if you find a variable that does work well with it, and it's probably you expect to see a lot of yellow from that.
Yeah, you'll see yellow, and if ideally you will the non-yellow things that you see will be scattered out, and there won't be a pattern to them. So yeah, you'll see lots of yellow, and you won't have very many, and they'll be scattered around. There won't be a pattern. This definitely looks like, the downtown corridor is an area of positive residuals, and the peripheria is an area of negative residuals. So if I look at the report, I'll be able to see what the strength of this relationship is, and I can see that it is significant still, okay? But look at the population coefficient. That's not very big, but it is significant, at least.
So don't you have to do something with that population by itself? Just doesn't tell the correct pitch. You have to add another variable to it.
And look at these residuals. Oh, sorry. Yeah, you're definitely going to have to add more variables to get this to make sense. Look at this residual chart. Totally different than the one that we were messing with before. See, it's clustered around. So in other words, in areas without much population, because that's what this bottom chart is. Okay, this is predicted call rate. Sorry, not population. In areas without much call rate, there's not very much there's not much error in the residual. But the error expands as we have more and more calls. As call rate goes up, we have more and more error in what we're seeing. So I told you before that if there's a pattern or a weirdness that's not just, this should be all random in here. And if it's not random, then I told you before that these two would be significant. And that's a problem. See how those two are significant? Those two statistics are significant. And that's telling us that we've got a problem there. Look at the R squared. It's also not very helpful, right? 0.39. Then the amount of variance that population explains on the number of 911 calls is only 40%. So the amount that they covary is very, very small. All right. We could go through each of those 6 steps. I think we went through most of them. Trying to think of one that I forgot, but we looked at the probability, we looked at the adjusted R square value, we looked at these two values, we looked at the pattern of the residuals, which there's definitely a pattern going on there. Oh, we could look at Moran's I. We could look at the global autocorrelation. Do you think it would say it's clustered or dispersed? It would definitely say it's clustered because it's it's all hot here, negative out here. We could run it just in case we wanted to, but it would definitely say it's clustered. Yeah. All right. So these are just the things that I actually ran. So what are the residuals and what do they show on the map? So the first question here is to look at this map and kind of describe it. And what are the residuals? What does the residual represent? What's being mapped? It's the difference between what and what.
What was expected and what was actually shown.
Right. How far off the model is. Okay. In each particular instance. Each one of these dots, each one of these block, or I think they're tracks. Each one of these tracks is a dot on all of these charts. So it's a dot on this chart. It's a dot on this chart. So this shows the relationship between population and calls. So in general, it goes up, right? But there's a lot of error here, a lot of residuals. The residuals are these distances between this line and each individual value. And so what you could say for the answer to that question is that the residuals show the difference between the model, the linear relationship between the variables, and the actual value for that variable. So, yeah, we opened the report. Okay, you can go through the statistics to see if your model is properly specified. Oh, we also forgot. Well, I was going to say we didn't look at the variable factor, but that's not really important because it's not. They don't even show it because it doesn't make sense because there's only one variable there. So. We only have one variable. Okay? So let's think about what are some other possible causes or contributing factors to 911 volume. Okay? So you could think of your own. Let's say that so you might expect more incidents as the number of people in the area. Oh, we already did that one. I scrolled up. Sorry. Okay. Now you will work with the 6 checks that are used to verify or specify a regression model. A model that you trust. Such a model, you can perform the 6 checks in any order. So we already did most of these. Let's see if I did them all. So.
So this might be a good one to do the exploratory one. I guess.
Yeah, you could definitely do it with the exploratory, but sometimes you don't get all of the outputs for the exploratory. But yeah, statistics in the report will help you. And for exploratory regression, it actually limits you to 4 variables at a time. Yeah, you'll notice that when I did it, it actually warned me because I clicked 5 and it said, we're only going to use 4. Okay.
Really, our distance to each other is probably the most important one because the closer they are to each other, the more they take one another. Maybe
Population density.
yeah, maybe because they're so close together, they now want to call because all kinds of stuff happens close to each other. So I would think that that's the important one, the fact that how close we are to each other, we make it known that.
I wonder if low income would like they have a car to drive to the hospital.
Yeah.
So you can call an ambulance or something like that.
Distance, income population, a lot of stuff like this should make them know that. Well, you know, I'm just eyeballing.
Yeah, so you're answering all these questions right here for the report this report that's just population. Okay? And so follow this through. So I actually answered a lot of these questions. Just do the independent explanatory variable, in this case it's just one, help your model. Okay. Are the relationships what you expected? Are any of the explanatory variables redundant? That one doesn't. So yeah.
Couldn't you do the nearest to see a relationship to the nearest?
Yeah, the data, it does include a distance from the city center already. But let's say that how would we create that? Well, if we had a polygon that represented the city center, then we could use that value, distance to urban center right there. So just for fun, we could now throw distance to urban center in there and run it again. Let's look at the residuals now. It's not letting me overwrite. There we go. So there are the residuals, and they do get a little bit more spread out, but they're still clustered there toward the middle. Because it almost seems like there's a corridor. So what's the overall R squared now? Oh, it's 0.60. That's getting reasonable. We still have a significant value for both the K statistic and the JB statistic. If we look at the thing, we still have some pattern going on here that we need to get rid of. But anyway, yeah, just go through and answer those questions. And then what you're going to do is you're going to develop a model that will look at more explanatory variables. So what you're going to do is run it again, but now you're going to include population, jobs, low education, and distance to urban center. And then once you do that, you'll do those. These are basically the 6 checks again, and then you'll answer these questions, and you'll do one using geographic weighted regression at the end. So you'll have the same ones and geographic related. Again, so think about why you wouldn't want to do geographic weighted regression, because that is one of the questions. Why not? Might be appropriate in this case. That's questions. All right. So basically, you're going to run 3 different regressions. You're going to run one, the one that we already ran. You're going to run one with all of these variables, and then you're going to run one with all these variables, which are the same variables, but you're going to do geographic weighted regression. Wait, no, there's 4 because you're going to use. And then you're going to turn in a map showing 911 calls and the predicted side by side. Okay, that's what I forgot to say. So one of the things we didn't do in class, so you're actually going to run 3 models, and then one thing we didn't do in class is how we make the predictions using geographic weighted regression. And so this step talks about that, this last one. So part 4 is actually making predictions using geographic weighted regression. So just follow the step through. If you have any questions, let me know.